section 12.3, geometric series. So always think sum when you see the word series. We'll do 12.3 is going to be only finite though, so the sum of a fixed number of terms. If you have a finite geometric series, and you know it's geometric because you're multiplying by a constant, then the sum of the first n terms in that sequence, the sum of the first n terms, as long as the common ratio is not 1. If the common ratio is 1, it becomes trivial to solve and we don't even need the formula. But you'll see why we can't use 1 in the formula. So the common ratio can't be 1 for this formula. And it is this. S sub n equals, you take the first term, a sub 1. So like for the sum of the first, say, 5 terms, s sub 5 equals the first term, you have to find that, times, and then it's just 1 minus the common ratio raised to the n power. So if it were the first 5 terms, n would be 5 over 1 minus r. And you can see that you can never divide by 0, and that's why this formula would not even work if r was 1, because you can't divide by 0. So, now, actually using this formula carefully is not that easy. It's very easy to mess up. So let's do an example just using the formula. So let's say I want to find the sum. You have to do order of operations carefully. Okay, so here's summation notation. The index number is going to go from 1 to 8. Find the sum of the first 8 terms of 6 times negative 2 raised to the I minus 1 power. Okay, so you might be thinking, looking at that, saying, how am I going to use that formula with this? Well, it turns out it's not that hard. If you just start expanding this, you can find the first term. So to use the formula, we know that n is what? How many terms? Number of terms? There are 8. So n is 8, so we got that. We need to find a sub 1 and r. We need to know only the first term and the ratio, and then we can plug in the formula. So the first term, well, you just have to plug in 1 into the expression. So for the first, so I just need the first term, and that would be 6 times negative 2 times 1 minus 1. All I did was expand this to find the first term. I don't need to know anything else. So that is simply 6 times negative 2 to the 0 power. And you all know anything to the 0 power is? Yes. So this is just 6. So in other words, if I were to expand this, it would be 6 plus something, all the way up to the first 8 terms. But all I need is a sub 1. The ratio is very easy to see when it's in this format, because you're always multiplying by, what can you tell? You're taking the first term and you're always multiplying by negative 2. So r is negative 2. You can see it from looking at the expression. You're always multiplying by negative 2. So we plug it into the formula. So s sub 8 equals, here we go, a sub 1 is 6 times 1 minus, now you must use parentheses around it if it's a negative number. That would be the most common mistake. You raise it to the 8th power, because n is 8, over 1 minus negative 2. Must use parentheses. Just always use parentheses. So here, this is really, you cannot say this is 1 plus 2. Everyone see that? You cannot say the numerator is 1 plus 2. You have to do negative 2 to the 8th power on your calculator, and then do 1 minus that. Or carefully type it in on your calculator using parentheses. The bottom, sure, we can say that's 1 plus 2. That's not a problem. Because we already did, there's no exponent that we have to do first. So sure, that's 1 plus 2. So you very, very carefully type that in on your calculator. I'm going to write out, this would be negative 2 to the 8th is a positive number. I'm pointing out the most common thing. Please don't make this mistake. Negative 2 to the 8th is a positive number. Then you're doing 1 minus that number. So it's going to be 1 minus 256 over 3. So if you take the time to just write out some of the steps as you're using your calculator, you won't mess up. So just do negative 2 to the 8th power, but be sure negative 2 is in parentheses. And then I'll take your question, and it's, so the answer is negative 510. Kylan, yes?
So why doesn't negative 2 become positive?
Oh, because any negative number raised to an even power would end up being positive. It's like squaring something. Like it'll end up being, if it were an odd power, it would stay negative. That's a great question. Thank you. Okay, so now I want to show you two things. I want to show you where this formula comes from, where this formula right here comes from, because you should be able to follow the proof. I wouldn't expect you to do the proof from scratch, but you should be able to answer questions about the proof. And you might see that in your SATs. And so I want to show you that, and then I want to show you an application. But they're both going to come from the book, so you don't have to write anything. So the proof for this is on page, maybe just write this down, on page 812 for the proof. And then we're going to also look at, for an application example, because there are, and they're interesting. Example 6 on page 813 for an application. So we'll go to, let's get this proof for geometric series. The sequence formulas we don't really need a proof for because it's just common sense. Those formulas are easy because, but the series ones are, when you're adding the sums. Okay, so we're looking at geometric series. It's right here. So the rule for S sub n. So the final formula is at the bottom. Formula is here. So how can we derive that? So what you do is first just look at this first line. This first line is S sub n. We're just looking at that. So is everyone okay with all that's saying is the sum of the first n terms is a sub 1. It's just notation. That's the first term. The second term would be a sub 1 times r. The third would be a sub 1 times r squared, r cubed, etc. because you just keep multiplying by your common ratio r, right? So that's just notation for writing out the sum of the sequence terms. And then by the end, you've multiplied by r n minus 1 times. In fact, that's the formula for the sequence that you already know. You used it in your warm-up today. A sub 1 times r to the n minus 1. So is everyone okay with that? Just writing it out? Okay, all I'm going to do is take that line and multiply every term by negative r. Just take every term. So a sub 1 times negative r gives you that. This times negative r gives you that. So basically, the exponent for r increases by 1, and every term becomes negative. That's what happens. If you write, now how you come up with that, don't worry about that. Just as long as you understand the notation, I'm multiplying everything in the top row by negative r. So that's how it changes. Okay, so this term becomes that. You're just adding 1 to the exponent each time. So you get an extra term at the end. Because if you added 1 to that, you would get r to the n. Okay, now we subtract the first line from the second. Now look at this, look how elegant it is. Because of the way it's all lined up, do you see how the opposite terms just add to nothing? Everything in the middle becomes 0. A sub 1 is still there, and A sub 1 r to the n is still there. Just the terms at the end are still left over. And this is just subtraction, just factoring out s sub n. And the last step, divide both sides by 1 minus r. If you divide both sides by 1 minus r, you will get s sub n equals this rule. And so it's divided by 1 minus r. And then you just factor out a sub 1. Right. That's the gist. Okay? So it just comes from the definition of a series and some clever algebra. All right, great. So that's that. And now an application, movie revenue. So we are right here, movie revenue. So in 1990, the box office revenue for U.S. movie theaters, $5.02 billion for the box office for all the movies in the U.S. From 1990 to 2003, the box office revenue increased by 5.9% per year. And this is something that movie theaters and maybe actors, I don't know, might be concerned about, because with technology, we're all renting movies on Redbox and or streaming it on. And, we're not going to movie theaters as often and paying $12 or whatever it is now. So it only increased by 5.9% per year. It'd be interesting to see what it is from 2003 to now. I would actually be interested if it's gone down. So write a rule for the total box office revenue in terms of the year, and n equals 1 represents 1990. So you're adding that should tell you for the total revenue that you should think, okay, geometric series, because you're always multiplying by something to do this increase of 5.9%, and you want the sum. When you want the sum, you should think series. So all you do for the nth year is you take the initial, and this should remind you of something. I'll ask you in a second. 5.02 billion, right? That's a sub 1. That's your first term. That's what you start with. What does it remind you of? Multiply by 1.059. What unit does that remind you of? The what? Decay, or the opposite of decay. In this case, growth, right? Exponential growth. Excellent. So you're multiplying by 1.059. That makes it, that automatically increases it 5.9% every time. Why do we have a 1 in there? You keep what you already had. That's why you need the 1. Okay, and then it's just raised to the n minus 1 power. That's your that's for the nth term for the sum. And then I'm sorry, this is to write a rule for the sequence. Okay, so this is just on a particular year, right? In terms of the year. Okay, important difference. So this was just a sequence for A. It just wants one particular year, and here's your formula for sequence, like we did in the warm-up. But then part B says, what's the total revenue for the entire period? Now you're doing the sum. Okay, so scratch what I started to say earlier. Now it's a sum for a 14-year period, S sub 14. You plug 14 into the formula, 105 billion from the period 90 to 2003. So when you do your applications, you have to think, do I just want one particular, like the amount on one day, or do I want the total sum for the whole month, or the whole sequence of years, or whatever? Any questions on that?